Hi, and welcome back to the Mob Mentality Show. My name is Chris Lucian, and my co-host is Austin Chadwick. And today our guest is Quinn Gil, and we're going to talk a little bit about object-oriented programming practices, maybe like micro objects and the definition of that, test-driven development, and discovery trees. But before we get into that, Quinn, maybe you can tell us a little bit about yourself and why you're passionate about all this.
Sure. So I've been a developer for about 25 years now, and throughout the entire course of that, I've always been trying to find ways to write better code so that it works better for me, more maintainable, more workable in the future, and for others. And the micro objects came about through some training and some other things, but it has made it really easy to work with code. I've done a presentation where we were able to deliver a feature set in 25% of the time compared to other teams. And once that hit, I actually it made me want to talk to people about these practices. Before, I hated talking to people. I would never be up in front of people. Like, coming on this would be the furthest thing from my mind before. But these practices make coding so much more fun and effective that I fundamentally wanted to share. I want to share these things with people. So I've done talks. I get to say now I'm international speaker on software practices. So that's the core thing of why I like these things and what I do.
Fantastic. Cool. Well, thanks for that intro. And I guess let's just dive right in. I guess that gives you a little background on why you're passionate about micro objects. I mean, I'm a little curious about the name. How did you come up with this name? What were you thinking with that?
Yeah. Early on, I was calling the kind of collection of practices like single responsibility to the extreme. So I take the idea of an object and a method should do a single thing, went to the extreme. That's just what I do in general. And it ended up very, very small classes. Like, they were one class that often had one method with one line in it. So they're very small, micro. So it just ended up micro objects. And it was at the same company when I was working with Steve Quo and Quentin Cortell, Paige Watson. I think you've had all of them on the show.
I
got a few more names I can drop later on. And we bounced the ideas around, and that one just kind of stuck because it seemed to fit well. Because it does create very small objects.
Maybe you can give us a little bit of maybe an introduction to what it means to be a micro object and how it acts on the world.
I mean, yeah. I actually realized a few years ago, talking with a colleague, that I follow these practices in such a way that what comes out of that is every concept that exists within the code is represented in the code. So if there's something as developers we could talk about as a thing within the system that we need to interact with, or something else needs to interact with, that should be an explicit representation in the code. There should be a class that has that name that we talk about. A little fuzzier than that, but that's the idea of, if you can talk about it, represent it. And so a lot of the practices help get the code there. My favorite one, and this I got from some training by Fred George, so I'm just going to drop names all the time here, is no getters and no setters. So no property. Then C# is my main language. I've worked in Java and Kotlin, but all languages tend to have something similar. When I talk about things, I'll probably reference C# structures. But no getters, no setters, no properties. Data gets into a class and will never leave that class. That's the biggest one. I worked with a team a few years ago to refactor some of their code to get to remove the getters and setters, and it ended up collapsing 3 levels of code interaction by removing it from this one base object.
Yep.
It just stop the data from flowing through the code, and everything simplifies.
Yeah. It's kind of this not necessarily feature envy, but it's like the lack of encapsulation means it's just like you're inviting people to come get your thing,
Yeah. Yeah, I remember that one because I've seen other nice transformations when I've worked with teams to do this, but that was the biggest kind of architectural decrease in a system that I've helped a team with. They unfortunately didn't have time to apply it everywhere, but it would have taken like 20 or 30 classes out of their system.
Well, I like it. So where would somebody start, or how would you suggest somebody starts on the path to refactoring to this sort of structure, or maybe even if they were greenfielding something, what would you suggest to someone just getting started?
So on the biggest ones, the no getters, no setters, is don't, which generally with C# or probably other language boils down to don't return class variables. So if you have a variable definition in your class, don't return that object. A lot of this in code will, if you give a class a string in the constructor, then you're going to store that in a variable and never return that variable. So if you need to do something with that variable, the class that holds it will do that thing. So it's classes should have behavior. It's object-oriented programming. So the behavior around data gets put into the class that holds that data.
Gotcha. Do you ever have DTOs or things that just like we were recently refactoring, and it was just like these 4 things always go together, and let's just put them in a thing and then pass them to the things that need it, as opposed to passing into 4 things around. Do you ever do that where they're basically it's just like a bag of things that are related?
I mean, I will create a class to encapsulate the relationship between those things, but a straight DTO, the data transfer objects, no. Okay. Because it's data. Like something's going to have to pull out a piece of that data and do something with it. Okay. So let's actually make it a proper class so you can give that behavior to the class that has the data. And if there is a lot of interaction between these data components, then they all should be in that class, but the behaviors around that data should be put into that class. I will say I do end up with DTOs at the edge of my system because I don't remember where I heard it, but I got that the edges of our system aren't object oriented. So I've always just said the edges of our the edge of a system plays by different rules, but I think the edges of our system is not object oriented is a great way to phrase that, because you got to do things a little different when data comes in and data goes out, because you are dealing with that at that point with data. The core of our system shouldn't have to pass data around.
Yeah, I'm trying to envision object-oriented bytes or JSON now, and it is exploding.
I've done that. It's different. I've had to loosen up a little bit around like how I interact with JSON. I used to be really strict about it. One of the big projects I did, Newtonsoft, which is the C# JSON parser, was only referenced in 2 classes in the entire system. Because one of the other practices is abstract third-party code. Yes. So Newtonsoft is a third-party library, so I didn't want reference to it scattered throughout the code. So I would encapsulate its behaviors, which was nice because I actually need some functionality that Newtonsoft didn't have, and I was able to put it in that one place, that one encapsulating class, and everywhere got the behavior for free.
Nice. Yeah, let me jump in real quick on that. We recently just felt that pain in our mob. So in a system we were just working in, we followed that rule for everything except one. And then we realized, oh, there's a good null object pattern refactoring, and we did it in a couple places, and it was really easy except for the one. And then that became very difficult because we didn't wrap the third-party code, and we kind of fell prey to like the testing environment making it easy to use the real thing as opposed to wrapping it. So we just like, oh, let's just roll with it for just this one. And then, it caused pain later. So I agree.
Yeah. And it's one of those like Newtonsoft as well. It's like, it's really easy to use. There's no external dependencies. It works, and you should trust it to work. But you do get into points where, especially with testing and JSON in particular, you have to craft actual JSON messages versus just returning the thing that the functionality cares about.
Nice. Oh, go ahead, Chris. You got one? Yeah.
Oh yeah, no, I'm trying to envision interactions with the edge of the system, and so maybe you do um you do kind of go outside of the norm for interacting with user interfaces and networks and things like that.
Yeah,
Yeah. But
definitely.
I was reading through some of these others, and so no new inline. I assume that's like factory related stuff, or
Well, not really. I actually I don't like factories.
yeah, okay,
I try to avoid
Ooh.
them. I have some in a recent code base where I call them generators so I can avoid the use of the word factory.
okay,
But in general, it gets back to the kind of the driving principle of these practices of a representation for the concept. A
Mhm.
factory isn't a concept of the system. You're like, that factory is not a concept of the system you're building. It's a
Mhm.
construct that we use to instantiate things, that we use as developers. So I try to minimize my use of factories because the system doesn't want them. The code the system we're building doesn't care about the factory. It's not a thing to it. It's a thing for us, generally for convenience. Most of the time I can find a way to refactor away from a factory. I just don't always. Because it is convenient. It is nice. It is easy. But it doesn't fit into one of the something the system cares about.
I see. I see. So yeah, you talking about taking things to the extreme, and I did have a question on that, but now I see it's almost like you don't want a thing to be a class unless it's like a domain idea. Is that kind of
Yeah.
what you're going
Yeah,
for?
it aligns with that. If
Okay.
it's not part of the domain, why is it a class?
Yeah, and I guess my follow-up question there is I'm a big believer in putting the domain into the code, but there's always been this line in the sand in every repo I've been in where it's like, here are things that are really easy to make domain, right? And name it
Mhm.
domain, name it domain. But then you get to a certain part of the code where it's so low level that like we need code to do a thing, but
Right.
it's not directly domain related. It's more like a hammer, right? It
Yeah.
doesn't matter if the hammer is being used for the Eiffel Tower or a storage facility, but the hammer is needed. And so what do you do with things like that if it's not directly domain related? Yeah.
Most of the time, yeah, you do get those low level things. We need to instantiate an HTTP client or a database client, and that's not part of the system we're building. Those do get just it's my I have monostate HTTP client, so I have a class specific for it, but it is used within a class that becomes a domain object. So we
Mm.
do have those classes that they are functional classes that they
Mm.
do a thing we have to have done. The domain doesn't actually care how that thing's done. So I consider those the way I talk about how this style evolves the system is you start to build functionality. So if you do vertical slices, you build down and then you get a little bit wide at the bottom. And the next piece you build, you'll use this same base, and that base slowly builds up. So you have a bigger set of foundational classes. Some of those will be domain related, some will be database, HTTP related, but you get this foundation of classes that can be customized to the solution you're working on that makes the vertical you have to build for each next piece get a little bit smaller and a little bit smaller so you can do really quick development of new functionality because you have all these objects that the system actually cares about already.
Nice. Yeah, nice. Yeah, and I think maybe that's getting into why it's less time, kind of that story you're telling at the beginning.
Mm-hmm. Yeah.
What was that? Maybe you can restate that story a little
Yeah.
bit.
So we had to build on a team. Basically, we had three teams: a iOS, Android, and then we got tasked with building a Windows Store app. So we were able to develop the Windows Store app in 25% of the dev hours. I got to lead half the team, and it was half the time. The metrics are probably a little bit better than that because I was only involved with a small amount of the code. I guided the team on applying these practices, and I wanted to ensure that nobody could use well, it's because you were on the team Which one of the managers afterwards actually tried to use that. I was like, well, is it because you were there? It's like, no, I wasn't there. We on our commits, we put our names of whoever's present, and my name was only on 10% of the commits. So I know I wasn't there for most of, for 90% of the code that was written. But overall, we were able to, with half the team, deliver in half the calendar time. And we didn't do crunch, or actually half the dev hours, because we didn't do crunch mode. We didn't do long nights. We would stop early if we got to a good break point.
Nice.
So we were able to really get a lot of functionality delivered. And a part of it was because we had the foundational things that made it so each new implementation was very shallow, started to get shallower and shallower. But also, as we built those domain objects, we could do composition a lot more, and the functionality existed. We just gave it the specific bits it needed to do slightly different things or to know different things.
Yeah, and I think that's I see you trying to explain it, and I remember trying to explain it too, and it feels like a difficult thing to explain.
Yeah,
yeah, because
yeah,
it's kind of like when you're following these practices, because at least a lot of these, I haven't read all of them yet in detail, but it's sometimes when you're like pairing or mobbing with someone, they're like, well, why are you doing this? You're like, well, there's a code smell here, and in my experience, when we need to extend this code later, it's much easier to read and do, or something like that, right?
right.
But I really like that example you gave, because that kind of it's alarming, right? Or people raise their eyebrows, like, oh, really? What did you say, 25% or half? Or
when I gave a presentation on that, I did an experience report at one of the XP conferences, and one of the developers that had been around much longer than me was like, yeah, applying these things, we were able to get like 10% time to deliver. So, and I've got this question. When I say 25%, it was, we were able to deliver in 25% of the time. So we saved 75% of the time.
Okay.
So it wasn't just 25% faster. No, it was 75% faster
Gotcha.
delivery of the features.
Gotcha.
So it can be huge.
Yeah. So do you think that's more? What do you attribute that most to? Is it like readability? Is it extensibility? Like you're saying, like, oh, a new feature is just a rearrangement and slight adjustment of existing micro objects. Is it eliminates waste of bugs, or like, what do you think the biggest contributor is there?
I think it's the ability to rearrange pieces and get entirely new functionality, which you can only do if your objects are really small and do one thing. There was single responsibility to the extreme, because then you can take the piece that does this and just substitute something else in it. It's like sorting algorithms, where you can inject the way to sort it. The sorting algorithm's the same. You're just telling it, ascending, descending.
Yeah.
It's the core functionality exactly the same. You just tell a little bit of a different thing.
Yeah. Nice.
So one of the things I work with Cosmos database in Azure a lot, and I have those kind of foundational classes for interacting with Cosmos. And the only thing I need to give it is like the database name and the collection name. So there's like two pieces of information I have to give it, and everything works, which, you can structure that for any database. But now when I want to create a collection, I just basically create one class that provides two different values, and I have the full database functionality available.
Yeah. It's almost like you're building a third-party library for yourself.
Yeah.
For your,
well, a lot of
domain.
times, a lot of times, like the Cosmos thing, that I put that in its own separate project. I kind of treat it like a separate library, not one I have to isolate, but it does get isolated just by nature of how I construct the domain things that hold like the database reference or the database client. I have one, and I'll let you go, Chris, but is kind of, like you said, single responsibility to the extreme. And I find myself, when I'm navigating that or suggesting that in an ensemble or a pair or even just to a team, you get a lot of raised eyebrows and a lot of skepticism and a lot of emotional shock when they start seeing it happen, right? And
How do you navigate that? What's your kind of go-to
Uh,
interpersonal moves there?
it ends up falling down to it makes the system easier to work with, more maintainable. It's hard to justify it, like to give that explanation, like you mentioned earlier, when there are a lot of little things that come out of doing it like this. There's no one big, oh yeah, this is the huge win from doing this. It's
Mm,
just all the little bits that come from not doing it, which might be a better way to look at it. Is it's less about what one of these practices, or like single responsibility, no getters, no setters, less about what it does and more about what it doesn't let you do anymore. I have found that a lot of these practices are less about being able to do more things, but actually end up doing less things within the code, which allows you to go faster.
mm. What bad things it stops you from doing? Nice.
I kind of like I kind of look at it like a lot of how I view TDD is TDD makes it really hard to do things in code, object-oriented code we know we shouldn't. You still can, it's just a lot harder to. These kind of practices do that same thing, is they make it harder to do things that make the code less maintainable.
Mm. Yeah, and that's what we say too, right? When before we walk away from a test, we say, if we were on a team a year from now and this test failed, would it stop the mutant, like the thing that was broken in the product code, and would it communicate it effectively enough that the person would not ignore the stop sign and blow past it and
Yeah.
delete the test, So yeah. Nice. Cool.
Yeah. Okay. So reading through some of the principles, I just I like a lot of these. So for years and years now, if only as guard clause has been a big thing for me. Switch and else are always evil also has been very big for me. No nulls I've adopted like more recently, where having like no op functions and things like that, where you can't actually pass a null into something. That's kind of relatively new. Yeah, the no new inline, also with like IOC containers and things like that sometimes for either object creation or reuse. And so extracting cohesion, maybe we can talk a little bit about that, because I know high cohesion and loose coupling, right? But what are your thoughts on extracting cohesion?
Yeah, I mean, some of these like extractor cohesion falls into just heavy refactoring.
Okay.
One of the practices, it's not how to write code, so I didn't really have it in this list, is ruthless refactoring.
Yeah.
Like you have to be merciless in your refactoring of code. And
like
the
it.
extract, what's that?
Oh, I was saying I like it. I mean,
Yeah,
I believe that.
ruthless.
Sure.
I'll talk about the extract cohesion in just a sec. I spent Friday night way too many hours because coding's my hobby. So after work, I still touch work code, but it's my time. I get to play with it however I want. I don't have to worry about building something. I just get to play.
Yeah.
I spent 6 hours refactoring code to change the fundamental architecture of the system because I didn't like the way it was going. Ran all my tests, still passed. ran the functions, made sure they worked. Like 6 hours changing the entire architecture of a huge chunk of the system, and everything worked. And it's like, it's so nice.
Yeah.
But for like extracting cohesion, this is generally like Austin mentioned about like, hey, we have an object where these 4 things get passed around all the time. But why do they get passed around all the time? Like, you're probably doing some data or checking between like at least 2 of those a little more often than with the other 2. So 2 of those variables probably interact a little bit more together than they do other ones. I always look at how can I pull these 2 out, or how could I pull 3 of them out so that I can create an object that handles the interactions of the last one and those 3. So it's looking at within a class, once you start getting variables in there, what methods are all touching the same variable, and can you extract those into their own thing? Or within this sometimes I'll write a giant method just to get the idea out. It's like, all right, this section of the method, I'll start adding white space. Like I break it down to like this section only touches these variables, this section only touches these variables. And like, then I know that I can extract those bits of code into new objects because they are highly cohesive. They all touch the same thing. If I have nice methods already and they all start interacting with the same variable, then hey, make that a class, return the class, and let something interact with that class instead of overloading this one.
Yeah.
My favorite example to go to for that is a person. A person has a birth date. So you can ask, you can create a method to ask their age. You can create a method to ask if they're, under 13, under certain ages. I work in the insurance industry, so certain ages are important. Are they a minor? Are they a major? Are they over 26? Those kind of things. And it can vary state by state that we insure in. So instead of having this person object have all these age-related classes, have it return a new age object that gets the birth date. And then that can have all the age-related methods, all the knowledge of how state requirements work. You might be able to break it down further within the age object to have collaborators and not have to know how to do everything itself, but knows what to use to do the work. Which that's a phrase I find myself saying a lot when I talk about these practices and how objects start to interact. Is it's not about having a class that does the work. It's about having a class that knows what class does the work.
Yeah.
That helps.
And then composition over inheritance. So
yeah.
Like I find myself using a lot of component models and passing around or rearranging functionality in that way. But maybe is that kind of what that looks like for you? Or
it's we don't want to get. I use it primarily to avoid giving behavior to an object by inheritance. That's what I want to avoid, because then the object you're creating is tightly coupled to the base class. So whatever changes happen there are forced on you. You have no choice. So I avoid inheritance for classes that do things. Unfortunately, I say this. My website says composition over inheritance. I actually often say composition never inheritance. But like I mentioned before about being able to just pass in a little bit of different information and get new behavior, I use inheritance for that. So I have my base class that does all the behavior and says, I need a database ID and a collection ID. So I use inheritance to pass in those two pieces of information. But the class that knows what that information is does nothing else. It's essentially an empty class, except knowing what to pass in. I refer to those as knowledge classes because they know what the actual class needs or what the actual functionality needs to do the job we want. So they know things, they don't do things.
Okay. Nice. And then no primitives. So maybe you can talk a little bit to that. Like, what does it look like to not have primitives? Is it just, something maybe has to implement a primitive at some point, or is it
something has to touch a primitive at some point. Generally, you want those at the edges of your system. So the edge of the system, data is coming in, like raw, primitive, bytes, strings, ints, whatever we want. Those come in. Those should immediately go into some class that's going to have a class variable that holds that primitive. At that point, that class is going to get passed around, not the primitive. The larger idea of this is primitives like an int or a string are generally not concepts the system cares about. So a string has meaning. It's something. It's a database name. It's a collection name. It's a username. It's a password. We want to interact with all of these very, very differently. So let's create an object to hold the raw data that actually constrains us to just the functionalities we want. Again, this kind of development largely starts to constrain what you can do, allowing you to go faster and not have to worry about the mess you're making as much.
You almost want to have name. You want to be guaranteed a name through like a class name or something for the primitive contained within, right? Or something like that. Like you have a password class that contains the string primitive that operates on that, but your business logic never passes a string around. It passes a password around.
Right. Yeah. So in the app we built, we had to do a login page. So we had a username field, a password field, which put the data into a username and a password class.
Interesting.
So they had the string class variables, but they allowed only the interactions that I wanted, and a password that was none. There has to be a way to get the data out for the edge of the system so I can pass it to the server. But I have different techniques for that. But yeah, in general, you want to represent the concept. You don't want raw data floating around your system because you don't know what it means. Fundamentally, you can name it whatever you want, but the interactions you can have with it are whatever that primitive allows, which is typically everything you can do with the primitive.
Got it.
Yeah.
Why? Oh, go ahead.
No, please go, Chris. Yeah.
I was gonna say, well, I was gonna move to the next one on this list, but which is no enums. So I was gonna ask why no enums.
Two reasons. They're primitives.
Okay.
The only thing, I mean, roughly primitives.
Yeah.
And to use an enum effectively within a system, you are building switch statements around it. So an enum tends to represent a collection of behavior. So instead of throughout the code making decisions about which behavior to implement or to use in that code flow, create classes for that enum which contain that behavior, which allows you to start getting into null object patterns, which Austin mentioned, which I have a blog post about null objects or superpowers because they simplify the code so much. But the just being able to return here the set of behavior you want instead of floating an enum throughout the system is going to simplify the system a lot. I've had to work in a code base where different enums had similar behavior. So you could just have it fall through to get to that behavior. I've had the default behavior be the right one. So as I'm going through trying to add a new enum and a new set of behavior to the system, it's not always easy to find everywhere that you actually have to go make a modification or know if an existing behavior is the right one. You got to go find it. Does this fall through to the default case? Do I have to go add a new case? A lot of decisions throughout the code. Whereas now I have a new set of behavior I want. I create a new class, and when that condition comes up, I return that class. I don't care where it's used throughout the system. I don't have to go find it in the system. If this new value comes in, it gets this new object guaranteed.
Awesome.
So it's using things, object-oriented strategy pattern, not object, but strategy pattern allows you to know that you're getting the right behavior in the right places and not have to worry about it or wonder, did I get everywhere?
Yeah. Is the enum doing this or that? And then the no logic in constructors. I think I try and get to a lot of that, more so using life cycles than the life cycle events rather than constructor logic. But yeah, I mean,
yeah, for me, the biggest thing with no logic in constructors is I think I like a system where the class will always instantiate. No matter what happens, you will get a class out of it. Whether that the data you gave the class is valid or not is an entirely different thing. So exceptions are going to happen at a different place in the code. But the part of this is also the two times I've spent way more hours than it should have taken me to figure out what the problem was both times a constructor throwing the exception. Just the error messaging, particularly in Java, is like, hey, I can't find the class. What do you mean you can't find the class? It's right there. I've since learned basically if you get a runtime error of class not found, it pretty much means the constructor is throwing an exception. But it is not clear what's going on.
Yeah.
And also, good.
No, please. Yeah.
Like unit testing as well. If I want to create an instance of something, I don't have to package up anything else. There's a minimal set of information I need to give a class. Often I try to get down to an empty constructor, which then I use a constructor chaining in C# to give it the additional components it needs. I can instantiate that class in a test and not worry about having to give it anything else, or it'll fail because, you didn't give it some configuration or you passed it a null or something. There's always, it'll work or it'll instantiate. Whether it'll behave properly, I'm not going to make any promises, but you will get an object back.
Nice. Yeah, that almost feels like the null object pattern a little bit. Yeah, it's almost like a little mini null object inside of every class. Yeah, and so I think one thing I've noticed with a lot of these patterns is, like you said, you're taking a lot of principles to the extreme, and it has its benefits. And I guess there's just some edge cases I'm wondering about, and I'm like your thoughts on. So one of them is kind of going back to the no constructor logic. That was one I had a question on too. So I'm currently working on a system where that is followed for every class except one. Like inside the constructor, all it does is it just assigns the dependencies. I guess it's not as minimal as you just said, but there's no logic in there. Yeah.
I mean, I don't like assigning class variables. You do that in the constructor. That's the only place you can do that, because you have setters.
Right.
So
exactly.
I don't. That's not logic though. That's just functionality of the language.
Yeah, exactly. And then, but there was one class where we did quote unquote have logic, and it was, we didn't want anyone to use this class without a certain thing being done, right? It would be very dangerous if someone instantiated this class without this thing being done. And so we did it in the constructor. What are your thoughts on that? Is there like a way to refactor out of that? Because you could take it out of the constructor, but then you're telling the client they have to remember to do a thing every time they instantiate it, right? And so,
I mean, they have to remember that anyways to get the constructor to work. But yeah, you don't have a forced way to do it. So if they have to like pass something in and then you use that thing, I will, to very strictly follow no logic in constructors, I'll store whatever that you need as a class variable, and then create essentially for internal use, and a method where I get that object and it will make sure that I have whatever the class has, whatever it needs, and then if not, throw an exception at that point.
I see.
So like when I'm accessing the database, I need a database client. So I have a class that essentially is like cache DB client. And so internally, to interact with the DB client, I just call the method cache DB client. So whatever instantiation, creation, validation has to happen, it's all contained within this cached method, which, it'll create it and then cache it, which is why I call it cached. It'll use that internally. And if that fails, it could throw an exception or cause whatever to happen.
Okay.
So like if there's a one-off of, we need to do this in the constructor because of, here's a really good reason. Okay. But yeah, that's how I get out of, in C#, there's also like the lazy singleton or lazy instantiation kind of objects you could use to handle that kind of stuff for you.
I'm reminded of the fluent builder pattern, but then you have setters.
Right.
Yeah.
Okay. Well, so in the interest of time, I think we should talk a little bit about unit testing and discovery trees. So maybe what were you thinking there?
So unit testing. I love test-driven development. This is my secret shame. I don't use it as much as I should. A lot of the times, like the current system I'm working on, I do heavy architectural refactoring while I'm trying to find the patterns that the code wants. And at that level, like I go from like 3 or 4 parameters to 1. And it's create a lot of other classes. So I end up having just the outer tests, the kind of behavioral tests versus micro tests, which make sure everything still works. And the insides, all the objects get created without TDD. There's test coverage, but not strict. Let's TDD up every class. And so secret shame, because I advocate TDD for everybody, and unless very specific conditions, you should probably be doing TDD.
Yeah. I mean, I'll jump in real quick and just say that I think one of the principles of TDD is you test drive what you know, but in that case, you're trying to discover the design you have. So to couple your tests to a design you don't know yet doesn't make sense. So just to have those kind of edge or sometimes they're called like Chicago or Detroit style tests on the edges while you're discovering the internal architecture, I don't think there should be any shame in that. At least my opinion.
Yeah. But like one of the things I was working on, I needed a lower level class, and I knew exactly what I had to do. So I started to write the code. I was like, no. When I did it TDD, because I try to when like you mentioned, I know what this class needs to do. So I'm going to write the tests for it, so I have them, so I don't have to worry about it later. But yeah, the architectural changes, and I know I do this when I'm given probably too much freedom on a system. I experiment. That's one of the reasons I love code. Is it is a creative experimentation platform. So I get to just spend hours and hours trying new things to see how the system behaves.
Nice.
All the tinkering.
Yeah, I tinker a lot, and one of there's this I can tinker like this confidently and comfortably now, because one of the biggest lessons I learned around code is throw it away if you don't like it. Yep. So I will spend like 6 hours refactoring something. I'm like, I've gotten myself into a state I don't like, and I can't really get it to a state I like. I'll just delete it. I'll just throw it all away. There was once, again on the Windows Store app we did, we spent 36 total hours. So there's 3 of us plus whatever time I was tinkering around at home. We spent about 40 hours refactoring the code base to implement this new pattern, so we could see what it was like. And one of the other devs on the team was like, I don't like it. And I was like, well, and I can't justify it. So get reset, get rid of it. We just, threw away days worth of work because it didn't really belong. It didn't work. And that was kind of like the system is better because we threw that away. Yeah. So now I'm happy. I'll go refactor for probably too much time, and like, didn't work, throw it away. Learn things, figure things out, learn new. Second attempt will be better.
And stretch the brain.
Yeah.
It's like defeating the sunk cost fallacy with code experiments, right? Yeah. Almost like it's painful, and we just went through one in my mob where it wasn't more than about 2 hours of experiments, but it was still painful to throw it away.
Right, yeah.
But we were like stretching the bounds of what we could test on the edge of the system. And at the end, it was like, this is no better than where we started. And then we're like, okay, let's put it in the trash. It was hard, but it was like, this is healthy. We need to burn this,
Yeah.
So I feel you.
Yeah, either that or you have to live with it forever. So.
Right. And if it's not a better solution, it's just more complexity, then it's actually a worse solution. So it's like, it's hard to get that refactoring that you're not really happy with as a better state of the code.
Yeah.
And like kind of back to the TDD aspect, one of the things or the way I view TDD is it is a tool that largely helps drive certain aspects into the code. So if you just follow TDD and don't try and be clever or creative, or if you don't try and abuse the code, you're going to get TDD forces certain things into the code. A lot of those would mimic some of the practices that of MicroObjects. You get similar things out of it. You're not going to have new inline, for example, with TDD. You're not going to instantiate a class within the code you're writing, because then how do you control what it does? You can't really test it. You have to do dependency inversion. So I've really studied like what I get out of TDD and what changes it forces into the code, so that I kind of write code that way the first time through without TDD. So it has a similar structure to it. So when I go back and write the test for the code, one, I'll find where I kind of screwed it up and testing's not as easy as I think it should be. So I'll learn something from that of, I didn't test this, and here's where I failed to make it testable. And that's really what TDD's emphasizing in the code, is let's make the code testable. So I look at it as both, I wish I was doing TDD on a lot of the stuff, but I actually learn what is and isn't testable within code when I don't, because then I got to go fix it. So I kind of use my my failures to TDD as a learning experience of why TDD is so beneficial.
All right. Quick soundbite on discovery trees.
They are a way to pre-break down the specific thing you're trying to work on and track it.
Okay.
It's very similar to story mapping, where you start to break down a thing and you put the stickies up on the wall, but those stickies have no context anymore. So discovery trees are essentially keeping the context of those stickies. So you start with one task, you break it down into a couple smaller tasks, pick one of those, break it down into smaller tasks. You keep repeating that process. Pick a thing, break it down in smaller tasks, and put the stickies up and draw lines between them so they all retain their context. And then you know, until you get down to something small enough to do in like 30 minutes to 2 hours. And so then you just keep working through that system, and anybody that comes along can look at the discovery tree and go, I know exactly what's being worked on and what's been done. So it's a great information radiator as well.
Yeah, no, it's great. And while we don't have time to dive deep into them, we'll definitely get some links from you in the show notes to dive more into that. And I guess I can just attest that we've used things very similar to discovery trees, if not by the book discovery trees, and it's incredibly helpful. So it goes hand in hand with a lot of the practices you're talking about. So
I don't think anything I'm talking about is like new or amazing.
New.
It's all amazing, but it's like it's nothing new. People have done this. People have learned about it. Some of these I've never heard of or seen written down. So I have a blog post which I'll give the link for the notes around discovery trees.
Nice, right on.
But yeah, it's all things I'm sure others have done because they're great things to be doing. Just sometimes I got to give them a name.
Fantastic. I know that naming process really helps a lot. And yeah, well, we're hitting our time box, and it sounds like Chris and I could walk through all of the MicroObject principles and
we could probably talk for hours on
conversation. Yeah, exactly. So tune in next week for a 10-hour episode with Quinn Gil. No, yeah. So but anything you want to share or plug before we close at least this episode?
I'll just go with, I don't have anything big to plug, but if you're interested in hearing more, my website, which will be a link in the show notes, I'm sure, quinngil.com. I got a lot of writing. I thought about these things for 5 years. They're all through writing blog posts. And while we didn't touch much on test-driven development, I have a bunch of posts on that, 90,000 words I counted using Word, but on how to do TDD like you mean it. So very strict, kind of TDD to the extreme seems to be a pattern for me.
Yes. Very good. Very, very good. Well, thanks, Quinn, for being on the show. It's a lot of pleasure. I learned a lot through this conversation, and I know many of our audience will as well. So we thank you for your time. And to our audience, please like and subscribe. Please share this video with anybody you want to have a conversation with about MicroObjects and these good principles and practices to make coding life more enjoyable, fun, and effective. And so, with that, mob on, MicroObject on, TDD on. Until next time, and talk to you later. Bye.
Bye, everybody.